Farmer Cheryl asked, what is the source of the fulvic acid and humic acids? What are the drawbacks of using them? So I'll give a quick course on just fulvic, I guess, where they come from and all of that. So great question, Cheryl. So fulvic humic acids, are could be decomposed plant matter that's a week old, all the way up to millions of years old, right? Could be veins of soft coal, leonardite, could be dead seafloor beds. So all of them have a lot of minerals for the most part, high mineral concentrations. The problem is fossilized versions and even peat bog derived, which is what I prefer certainly for humans and animals, is because they're bioavailable. They're already bioavailable. But they'll use hydrochloric acids to remove the fulvic humic from the shale, the dead seafloor bed, even the peat that comes from a peat bog. That's not what we do. We don't do that. The reason we don't do that is because, one, the hydrochloric acid and other chemicals are toxic. Two, you throw the biology, if it exists at that sediment layer, into such a tizzy that nature is going to fight back, and you'll get an explosion of bacteria to digest the chemicals and break them down. That's just nature fighting back. And so then they have to pasteurize it and cook it and kill it. And so it's denatured, right? So we use natural processes with our humates that come from peat bogs, natural filtration that removes the fulvic humic. That way the biology stays in balance, a pristine, perfect balance of the soil-borne probiotics. And then it's flash frozen under extreme pressure and suspended in time, so to speak. So when you put that back in water and spray your plants with it as one of the components of the program, it creates massive amounts of genetic expression in the plants just by itself. We've had tests done on the components of all the components of the program, and the yields and Brix ratings and all those things just by themselves have been through the roof. So so that's why we do that. I'm not going to put it in my kids, right? It always goes back to what am I willing to put in my kids? Now, if I'm putting something in soil, I can use a diversity of mineralization that's not bioavailable, because I'm going to pound it with a lot of diversity of microbes to digest it and break it down for the plants and make it bioavailable. And that's when it, obviously creates vitality and immune function for the soil and the plants. So there you go.
Well, and that's the key is, having that extra biology in there, because it doesn't matter what the molecule is. Mother Nature has already developed species of biology that can break it down to its core components. What we're missing is the biology that is necessary to do that. And Terry just came up with a question. I haven't even had a chance to read it yet. I thought Brix was sugar content.
Sugars and salts, yes. But mineralization, that's nutrients, all of those things, genetic expression in a plant to create the high Brix ratings. That's what that's about. And that's what makes that fruit or vegetable resistant to frost, resistant to bugs, all these different elements that protect it, right?
Without the mineralization, you can't have the complex sugars, so you can't have the higher Brix rating. That's why Andy and I did a show on Brix. I think it was just this past week where we were talking about that. You need both. You need the molecules of the micronutrients, and there's 97 out there that is really necessary, and then you need the biology to use those to build these cells, put them together. So it's a combination of everything. But I want to keep it at an hour with you today, Pat, and we can always have you back on more.